right, good morning for some of you. Long time no see, as in about 25 minutes. Today we're going to do a quick little hit on some things that I know will come up for surely in multiple choice, if not also in free response. So I want to make sure that we have an understanding, because we should be able to get all these points every single time. So it's mass spectroscopy and photoelectron spectroscopy. And I have four different graphs. And I'm trying to figure out what I can do here. So let's take a look at the first one. Just multiple choice, but just do you understand what it all looks like? You had a multiple choice question like this a couple days ago, about a week ago, that you had to submit. But this is a mass spectrum. And that's not on. That's great. So it's all based on mass. So you have all these different peaks. When you throw this into the measuring instrument, the different isotopes basically shoot, and they can figure out what the masses are by peak and the relative abundance. So this peak line is how many times they're sensing that this atom or isotope has a mass of 90. So the higher the peak, the more often the more occurrences, the relative abundance. And then so on and so forth, and you see some 91s, 92s, 94s, and a little 96. So, multiple choice, what is this element? So you could look at them all, and that's really far away for me to see some of the masses. We'll see what we can do. So Y has a mass of, what is that, 88.9. I'm going to write them all on the side ones. So help me out if you can see some of the other ones for me. Just use print sheets. I don't have that. 91.2. NB is 92.9. And MO is 95.95-ish, according to this one. So just based on that, this is all this question is. It's an average question. It's just averages. So looking at the overall idea of what you have, it can't be 88.9, because there isn't even an atom that has something under the 90 or under 90, right? So it can't be that one. So what is it? What do you think that would be? B or C? It's letter B. It's got to be letter B. She's like, well, why can't it be C? If you look at C, you're saying that the mass average is right here. Okay, it cannot be D, because that's saying it's way down here. It's basically that peak. So 91.92 is right there. If you kind of look at that makes sense. It's closer to the largest peak, right? But it does bleed away from them, because obviously there are some other atoms that had masses as well. So that's all you have to do for that interpretation. We had that question once before, something similar. So you got to kind of be mindful that all it is really an average. So I want to just touch on that again. Leading into the next. This is a photoelectron spectrum, also referred to as PES. And you guys are very good at this last time we did this, so let's talk about it again. It says relative number of electrons. You got to be very careful. You have to understand the scale. Sometimes those lines mean 1, sometimes they mean 2. Like, you got to figure out what it means. Underneath, it's binding energy. What this is, it's the amount of energy it takes to remove the electron, how tightly it is. Another way to think about it, though, guys, it's distance. It's not technically this answer, but it's distance from nucleus. Just telling you that's what it's going to be. Because the closer you are, the more difficult it is to remove, the more energy it takes. Anybody know what these two hash marks mean? Right down here. What do you think that would mean? Not change energy. Breaking graph, so it's not a scale, though. It's not the scale then anymore. So it just not scaled. It's a break in the graph, technically. I mean, but just I don't want you to get confused by that, because it's like they could have a little bit here, and then the next one's way down here. It's not like you're going to now unfold your page to see the rest. So you're going to see breaks in the graph from time to time. So it's not scaled. That says scaled, even though it looks like it says sealed. So this is where, if you don't know what you're looking at, this is almost impossible. These are what you could almost consider, this is the amount of energy it takes to remove each electron. Okay, so it gets easier and easier and easier. You could think of it potentially as ionization energies, but it's not technically. So this peak is relative number of electrons. If this is the nucleus right here, wow, can I misspell that more? Because that would be awesome. I'm working outward. These are shells, okay? These are literal shells. I'm working outward. So if I'm working outward, oh, come on. It's all or nothing. That's great. What's my first peak if I have a really big atom and I have to start placing electrons? What's the first thing you'd say? 1s2. You have to live on that first or else nothing else makes sense. So that's my 1s2 peak. The first peak, the one closest to the nucleus, now it's not always left to right, the largest binding energy will be 1s2. Because of that, this line is worth 2 electrons. So this is 2 electrons. This is probably 4. This is probably 6. So now I can start placing them. The next part should make sense. This is 2s2. What's the next peak? 2p6, and it went up to 6, right? 2, 4, 6. So let's fill out the rest. This is 3s2. Notice there's some more space because there's areas, there's nodes they're called, where there is no activity at all versus activity. That's 3p6, and then 4s2. So it says that was the identification of it. When two elements combine to form an ionic compound, here's the question now to it. The sum of their charges is 0. For example, Mg2 plus and Cl minus form neutral compound MgCl2. Element X, which is above, would most likely form which of the following compounds? So it's X. So what they're trying to do is show you a couple different solutions that it could go with. So let's talk about that first off. Is it the first two are showing that they're negative charges. The last two are showing that it's a positive ion. So is it an anion or a cation if it became an ion? Right now it's not an ion, it's an atom. But if it lost its 2 electrons, its valence electrons, is it a cat or a gain? Is this a cation or an anion? You know, better, let's just identify this. What atom is this? What's 4s2? Calcium. Let's do that. Is Libby in here? Libby, what is that then? A cation or an anion? It's a cation, yeah, it's cation. So, which ones can I cross out right away? A and B or C and D? Which one do these not reflect? They are not A and B because they're saying those are negative. So which one is it? C or D? C? Because O is 2 minus, so this would work like that. And Cl is minus 1, so the 2 would come down. So it's definitely C. But the problem isn't actually the answers. The problem was, did you understand what the heck you're looking at in the first place? I'm looking at Ca. I have to identify that it's Ca. Okay, let's follow up. So here we go. The following PES spectra are for 2 elements that combine with each other to form binary compounds. Now, we may not do every single answer here depending on time, but what I'd like you to do right now, and you can work with someone else afterwards if you want to check it out, I want you to write on all those peaks, and I want you then to answer letter A. So I want you to write the electron configuration completely, so write it all out then, but if you want to, I'd like you to write on the actual peaks first. I want the electron configurations for both A and B, and then I want to know what they are. So let's do that first. Be very careful. Sometimes lines are worth 2, sometimes lines are worth 1. You will know after you see the first peak, because the first peak is always -2. So you can kind of tell, like, oh, hey, wait a minute. I went up 2 lines or 1. Confused? Someone definitely can, maybe they're getting a little bit more in the beginning. Figure it out. Stuck. It's got to be 1s2, right, in the beginning? Has to be 1s2. Chris, what's that last peak on the first one? What did you do? 3p2, I agree. Same height, right? Same height, next peak. Peaks are all the sublevels combined. Like all the electrons in that one sublevel. Emma, what'd you do for the last peak on this one? Yeah. 3p5, yeah, it's in the middle. Right? The top line would be a 6. The second line would be a 4. So that should be a 3p5. So if we identify these, all we got to do is continue to remember some things that we learned a long time ago. That's why they're harder to bring back. You have the p block. 3p2 would be silicone, and 3p5 is chlorine. Okay. Why do the two s electrons have different energies for the two elements? They have different energies. Right, so this is 26, and this is only 15. Right? Okay. Perfect. What's the money word? Anybody want to, when I want to talk about the nucleus? Nuclear charge. You don't have to say it, but if you do, that is the money term. So, you're right though. Nice work. Is that it? So the bottom one, it should make sense that it's a larger value, right? Because the 2s2 in chlorine is held tighter due to a higher nuclear charge. Perfect. Okay, so there's a lot of other questions on here, and if you, I don't want you to get confused. Like it says, it contains 1 gram of the element and 5 grams of the other one. In the beginning, all you're needing to do on that one, and we're not going to spend a lot of time on that, is because you knew what element it was, you take 1 gram and you divide it by its molar mass. Take 1 gram and divide it by its molar mass. What they're doing is setting it up eventually for some ratios coming down here. So, determine the number of molars of elements that react 1 gram. See, okay. My plan wasn't really to work on a lot of these other ones. So, to kind of finish this up, we're only like 2 minutes away. Is that the other thing sometimes you'll see is this, just FYI. And you don't have to write this down. I just wanted to show you that they'll do 6 lines. Do not freak out. Like all of a sudden you see a peak. Let me do a different color. I see students all the time understanding the beginning part, and then all of a sudden they make up new numbers. Like they call this 1s4. I mean, like you just blow up your mind. Like, I guess we're doing that now. It's like, no, that must be 1 electron each. Like that's actually more common that I see that way than others. The one I hate the most, just showing you this now, and I know that I'm drawing it, so it's not great. I've seen this, where it literally looks like this. And then it'll be something like that, and you, like, that's it. Like, that's it. So it's like, well, I got to realize that this height, I almost made it, is 2. And it's not like you're going to have to take a ruler and be like, oh my gosh, I'm off by 0.5 millimeter, I don't know what to do here. But if you're sitting there and goes, oh my gosh, like I don't even have 1 electron? I don't even have 1? What is this? The first peak, just to finish up today, you got to just make yourself, first it's 1s2. Everything else is a variance off of that. Okay? So I think we can definitely handle that stuff. I was wanting to make sure that we go through that, and in class is not always the best time to get all this other in. So we have about 2 minutes. You can definitely just chill out.